Okay. So that was easy. That's not a problem. Okay, so arithmetic sequences. This is a revision from 2 weeks ago. Arithmetic sequences. They go up by a common arithmetic or a common difference. The way it works, so an arithmetic sequence can be generalized in the following manner. Start with A and then keep on adding D, any number. So if it's A, the first one, then the next one must be A plus D, the next one must be A plus D plus another D, which is A plus 2D, and then you add another D, becomes A plus 3D, and so on. So we can see that the number of Ds added on is always one less than the position of a term in the sequence. Oh yeah, that's a good way of thinking about it, but in other words, the general rule for the term is T of n, which equals to A plus n minus 1 D. The common difference can be found by subtracting your second term from your first term, or your third term from your second term, or any term subtracted the one just before it. Will always equal to D. So this question says find the 20th term. When it says find the 20th term, we know that that means n equals 20. So find the 20th term. And the general term for the arithmetic progression whose first term is 5, so A equals to 5. And the common difference is 3, which means D equals to 3. So we'll just plug it into this. T20 equals A plus n minus 1 times D. And then you just plug it in. 5 plus 19 times 3 equals 62. And then it says find the general term. General term just means Tn. So Tn would equal to 5 plus n minus 1 times 3. Expand it, that becomes 3n. Take away 3 plus 5, positive 2. Okay, any questions up to this stage?
No.
Yeah. No, show that 15 form an arithmetic progression. So show that this forms an arithmetic progression. For this to show, for this to be an arithmetic compared to a geometric, 11 take away 15 must be the same as 7 take away 11, which must be the same as, like, for example, 3 take away 7. And we can probably see all of them give us -4. So therefore, it's an AP. And hence find T25. Well, T25 just means A equals to 15, N equals to negative, sorry, not N. I can't hear you saying, ooh. Steph, you can still hear me, right?
Yep.
Okay, let's see what's happening there. Azra, can you hear me now?
Yeah, it's better now.
Okay. AP, so T20, where was I? T25, yeah. The common difference is -4, so therefore, yeah, you just get A plus n minus 1 times D, which is -4. And then it says Tm plus 3. Again, that just means A plus n is n plus 3 minus 1 times D. Well, and then 3 take away 1 is 2, just expand and simplify it. Any questions up to here?
No.
Okay. Show that this sequence defined is an arithmetic progression. Okay, example 7. How are we going to show that this is an arithmetic progression? Any ideas? How would you show something's an arithmetic? What did we do here to show that it was an arithmetic? We had the first 4 numbers, and then we found the
Find D.
Found D. In this case, we don't exactly have D, so what are you going to do? You're going to create T what?
1.
Yeah, and T.
2.
And T.
3.
And then hopefully, when you get this number, and this number, and this number, you're going to subtract them and find the common difference. Can you girls just quickly do that?
Yeah.
Excuse me. Do we have an answer yet?
Yep, I have D equals 3.
Azra, do you agree?
Yeah.
And we kinda can know D equals to 3 just for your own curiosity, because you learned y equals mx plus b, where m was your gradient, and that tells you how far everything's just going up every this much. So you can straight away tell D must equal to 3 if this is just going to be a straight line as well. It's just another way of doing it. But you wouldn't have shown it's an, I guess, an arithmetic by just going, oh yeah, therefore it's D equals 3. You had to actually show what you girls would have done, which is, yeah, showing your first term, your second term, your third term, and then subtract it to get D equals 3. Show that the sequence defined by this is not an arithmetic progression. Okay, hopefully it doesn't work out. So go and do the same thing. What's the answer for T1? 1 plus 3, 4. 2 squared. 4 plus 6, 10. 3 squared, 9. 9 plus 9, 18. T3 take away T2 equals 8. T2 take away T1 equals 6. 8 does not equal 6, not AP. Simple?
Yep.
If the fifth term of an AP, this is what we were doing last week, sorry, the week before. If the fifth term, straight away I write n equals 5, of an AP is 43, that means T5 equals 43. And the 12th term is 99. T12 equals 99. Find the AP, find the actual arithmetic progression. What must we do? When we know T5 equals 43, we're going to sub it in to this, and then eventually what will we need to do?
Find A and D.
Using what technique?
Simultaneous equations.
Yeah, you're already getting used to that. That's great. So A plus 4D, T5 is 43. Okay. I'll leave the rest to you girls. 99. A plus, I'll tell you what the next one is, 11D. Go. Use that as equation 1. That is equation 2. Find me what A and D is. Say the answer when you know it.
Okay, I got D equals 8 and A equals 11.
Say that again.
I got A equals 11 and D equals 8.
A equals 11 and D equals 8. Okay, Ezra?
Yeah, I got the same.
Okay. Find AP if T2 plus T7. Okay, I'm going to leave it with you. Let's see what happens with this one. I'm going to try to say nothing. So, T2 plus T7 equals 31. T5 plus T12 equals 103.
I got D equals 9, A equals negative 16.
D equals 9, A equals negative 16. Beautiful. And then, of course, if it says find the AP, you have to actually start with negative 16 and just add 9 a few times. Any questions? Steph, how'd you go? Are you stuck?
No, I'm still working it out.
Cool. Did you get your first equation as 2A plus 7D equals 31?
Yep.
And then 2A plus 15D equals 103? All right, cool.
Yep.
You should get it out then.
Was A negative 16 and D equals 9?
Yep.
Okay. Yep.
Beautiful. Let's go to the next bit then, GP. So geometric series are going up by a common ratio. The way it works is you start, your first one's technically A, the next one's AR, then AR squared, then AR cubed, and so on. So in other words, your Tn becomes A to R to the power of n minus 1. To find your common ratio, it's going to be the second term divided by the first term, and then the third term divided by the second term, and so on. So I think we can do this. So I'm just going to try to jump onto these harder ones, do one or two, and then move on. Yeah, let's do example 15. Again, I'm going to try to say nothing. I think you girls look like you're smashing it, so I'll leave it with you.
What does it mean, the general term?
So this is the general term, the nth term.
Okay.
So you need to find A, you need to find R, you can leave n minus 1.
Okay. Sam, I think I need help with this one.
It's because of the simultaneous bit, right? Is that where you're stuck?
Yeah.
Yeah, all good. What about you, Ezra?
No, I'm done.
Done? Okay,
Yeah.
what did you get? Example 15.
I got I equals 2, A equals 9, and the equation was
A equals
Tn
9,
equals.
R equals.
Yeah.
Yeah, done. All right, let's do it. So,
I got
let's
those
start.
equations.
Wait, so you got these two equations, 288 equals AR5
Yeah.
and 36. Okay, and all you would do then
Yeah, I got
is
that.
make A the subject. So you, like in this one,
Yeah.
A becomes 36 on R squared, and A equals 288 on R5. Then make A equal to A if you want. Or you could have just subbed it in, it doesn't really matter. 36 on R squared equals 288 on R to the power 5. Cross multiply, and eventually cancel out. Or if you didn't make it equal to, you just decided to sub it in. Yeah, let's rub all this out. There we go. Oh, too much. A equals 36 on R squared. Sub this into this A. So get rid of that. It becomes 288 equals 36 on R squared times R5. Of course, that becomes the power of 3. Divide by 36, which looks like it's 8. And then equals R cubed, cube root it. Does that make sense?
Yeah.
All right. And then obviously once you find R, just sub it into here, 36 over 4, which gives you 9 eventually for A. All right. Okay, summing arithmetic, as long as you know it's a summation question, really, your A and D, same logic. So I'm just going to jump straight into the harder questions. Oh, okay. Like this one, find the sum. No, they're too easy. All right, then we did limiting sum. Limiting sum, we realized that was for infinity. So it goes on forever. And the formula was this. S of infinity equals A on 1 minus R. And it's important to note, because a lot of students don't know this, R, for it to be a limiting sum, R actually must be between -1 and 1. So you can't do a limiting sum where your ratio is like 2. And you can't include 1 or -1, just so you know. Okay. Explain why the following have a limiting sum and then determine the value of the limiting sum. Okay. For it to have a limiting sum, R must be between -1 and 1. So that's something you're hopefully going to show. And then determine the value. Determine the value is A on 1 minus R. So go and work out A and B, please. I'll be right back. Okay, I'm back. How did we go? A and B. You get it out?
Don't think I got it.
26. Let's have a look. So, all you were trying to say was that your R is going to be negative a third, which is between negative 1 and 1. Did you get negative a third out, Steph?
No.
How do I find R? Isn't it the second term divided by the first term?
Yeah.
So negative 6 divided by 18 gets you negative a third. And then, of course, since that's between negative 1 and 1, this is a limiting sum. And then to do it, your sum equals 18 on, A on, 1 minus R. So 18 on, 1 minus negative a third, and then plug it in. Same thing with this guy. You'll just do the second term divided by the first term. So root 2 divided by 2. And then since, again, it's between negative 1 and 1, like that gives you 0.7 when you plug it into your calculator. Therefore, it has a limiting sum, and then, of course, just A on 1 minus R. And that gives you 6.83 or whatever.
I just did the R the wrong way.
You did the first one divided by the second?
Yeah.
Right. It's always going to be second. Azra, any questions from you?
No.
The other guys seriously didn't come in today. No, that's funny. I'll give him another call. All right. For what values of x, this is a typical exam question. For what values of x do the following have a limiting sum? Now, most students just get used to work out the limiting sum, work out the limiting sum, work out the limiting sum. And what they don't get asked very often in textbook questions is, for what values of x will this have a limiting sum? For that to occur, you actually need to use this. Well, you wouldn't say it's a formula, but it's a condition. But you would have to use this particular formula. All right. So for this to have a limiting sum, we know that it's going up by x minus 2. So your ratio must be x minus 2 must be between negative 1 and 1. Does that make sense, Steph?
Yeah.
Do you understand that the ratio is x minus 2? Because this divided by this is x minus 2. Or this divided by this. So it must be between this, and then obviously to solve for x, you're going to just add 2 to everything. So 1, as long as x is between 1 and 3, this will always have a limiting sum. So for what values of x will do the following have a limiting sum? As long as x is between 1 and 3, this will always have a limiting sum. Cool?
Yep.
The same thing with this one. So what's your R? What's your common ratio straight away? Can you see it?
2 over x.
Yeah, right. It's just this divided by this, which is just 2 over x. So as long as it's between negative 1 and 1, it should work out. So what are you going to do when it's like this? Well, you'll multiply everything by x, which looks really strange, doesn't it?
Yeah.
So what we do whenever we see something like this, we break them up. So what we'll do is go negative x less than 2 and 2 less than x. So you actually just break it up. You'll solve for this one. So if negative x is less than 2, when you divide by negative 1, you'll get x is bigger than negative 2, right? Because you divide, you have to flip the sign. And this one, and this one, I mean, there's not much you can do. You can just bring the x over. So you can write x is bigger than 2. If you rearrange it. So as long as x is greater than negative 2 and x is greater than 2, no, something's gone wrong, Sam. What have you done? Negative x less than 2 less than x. Negative x less than 2. 2 less than x. That means x is greater than negative 2. Yep, x is greater than 2. Fair enough. Maybe we should put on a number line and see what's happening. Negative 2 and 2. Pick open circle, test x equals 0. If I test 0, is 0 less than 2 and 2 is less than 0? No, that doesn't work out. What is happening? Interesting. If I said 3, greater than 2, so 3. Negative 1, is that less than is that less than 2 1/3, and is that less than 1? Yes. I see what you're trying to tell me to do. Okay, fair enough. So it's only this. So it's this guy, but then this guy can't win. All right, you ready? Bit of a trickier one. So we do it exactly what I've shown. It's fine. The answer we're getting is x is bigger than negative 2. So if you think of it in terms of a number line, x has to be bigger than negative 2, but and x also has to be bigger than 2. So if x has to be bigger than negative 2 and x must be bigger than 2, what's your final answer? X must be bigger than just 2. Because then that would be true for this one and for this one. Azra, do you get that?
Yeah.
Okay, Steph, do you get that?
Yeah.
Are you sure? Azra might get it only because we've been doing this in year year 11.
Yeah. Yeah.
Like, look, if I told you a number has to be bigger than 5 and a number has to be bigger than 6, so therefore the number must be
Bigger than 6.
Yeah, because if you just say it's bigger than 5, well, yeah, it's bigger than 5, but it's not bigger than 6. So like if you had 5.2, yeah, that's bigger than 5, but that's not bigger than 6 yet. So unfortunately, that's not good enough. So you've got to choose the bigger one. So if a number has to be bigger than negative 2 and 2, obviously the whole number must be bigger than 2. And all I was doing up here was I was just testing for myself just to see, like I tested 0 and it didn't work. So I knew these numbers are not going to work for all of the cases. And then I realized it's going to be 3. And then you can see I tested it. I subbed in 3 to here. I got negative 1 is less than 2/3. Yes, it is. And is 2/3 less than 1? Yep. And then any number you're going to pick now, like 10, is negative 1 smaller than 2 over 10? Yes. And is 2 over 10 smaller than 1? Yes. So any number would work after 2.
Yep.
Fraction cases, that's out of the syllabus. And then we got to the applications of AP and GP. Oh no, we didn't do much application questions. I think I left that and we went straight to compound interest and stuff. All right, so we get a good amount of time to do these application questions. Cool. Before I start on these, I'll just want to check if the application questions are still the same with this new syllabus. So let's make sure. Let's use this. Yeah, so these are basic GPs. Basic limiting sum. And that's it, right? Okay, so that's that. I got that. We've already covered all that. And then the other one is this one. Okay, let's see what 1201 is. Whoa, too much. Yeah. So this is the application. All right, cool. So they just changed the word, calling it geometric growth of decay. All right, all good. I got it. Okay, easy. And then pretty much our compound interest and stuff that we're doing. Good, no problemo. What is this? Let's do this application. So for application questions, I've just started with a HSC question. I think it's a really good way to start because they're not too hard. I don't believe they're too hard, but it will really show if you actually understand what is happening and how everything's working in terms of your APs and GPs. Now, it won't tell you it's an AP and GP. You have to identify if it's an AP or GP. Cool. And the way you're going to identify it, of course, is either finding your common difference or ratio. Let's read this and let me know if you're finding it comfortable. On the first day of the harvest, an orchard produces 560 kilograms of fruit. Already A would equal to 560, right? On the next day, the orchid produces 543. So, and then my sequence, so maybe I should start a sequence here first. So 560 and then 543. It continues to decrease by the same amount each day. Well, that would mean it's going down by 17. So then the next one would be 543 take away 17. Which is 526, take away 17. We get the idea of that now, and so on. From that, before I even start, I now know that A equals to 560, and my common difference is this take away this, which is negative 17. It's obviously not increasing, it's decreasing. And then I. How much fruit is produced on the 14th day? Does anyone have any idea of how I'm going to be able to do this? Or what you're looking for? Are you looking for the sum? Are you looking for the nth term? What do we think?
Are you looking for the term?
You are. You're looking for the term, and which term specifically? T what?
13?
No, T14.
15.
You're overthinking that. Don't make it too complicated. You're finding the 14th term. So on the 14th day. That was the first day, T1. Second day, T2. Third day, T3. 14th day, T14.
I thought it was, that would be during the 14th day if I'd find 13 or something.
Yeah, technically. I get it. I get what you're saying. Yeah, no, not like that. That would be, yeah, what you're saying. It's like during, like how much did you go through during that 14th day? You would say, I don't know, T15 take away T14 or something like that.
Yeah.
T14 equals A plus N minus 1 times D. You got yourself 2 marks in the HSC. $339. Double A. What is the total amount of fruit that is produced in the first 14 days of the harvest? Azra, any ideas on how to do that one? Double A.
That would be a sum.
That is a sum. Sum of how many days again? 14 it's saying. And the formula is n over 2 bracket 2a plus bracket n minus 1 d. N equals 14 over 2 times a plus n minus 1 times d. Plug it all into your calculator. Six two 9 3. Any questions about that? 2 out of 2, 1 out of 1. On what day? On what day? What are you trying to find? On what day? Azra, what am I trying to find? It says on what day?
Term.
Not exactly term. No, I'm not going to say term. On what day?
Do you have to find n?
Yeah, it would be more n. On what day does the daily production first fall below 60 kilograms? So pretty much you want to find when Tn, the nth term, is less than 60 kilograms. Right? But on what day you want to work out the n? The Tn, the nth term, has to be less than 60. Does that make sense? So Tn is A 560 plus n minus 1 times D is less than 60. And then, of course, I think you know what you're going to do. 60, take away 560, expand this. 60 take away 560 is negative 500. Take away 15, negative 17n, negative 517. Oh, yeah. And then n is greater than 30.41. So that means on the 30th day, it will fall. On the 30th day, it's still at like 61 or 62 kilograms or whatever. So that means on what day will the production first fall below? When n equals 31 days. Does that make sense? On the 30th day, when you hit the 30th day, you will be at like 65 kilograms, let's call it. But when you hit n equals 31, the 31st day, you actually hit below 60 kg. Steph, Azra, make sense?
Yeah.
Was I right in assuming that we could just start like this, or do you guys need more work on, like, I'll give you more work, that's not the problem. Like, do we need to do more basic questions, or was that fine to start with HSC questions?
Questions like that is good for me anyway.
Yeah, cool. Yeah, they're just good HSC. That's just, I mean, that's what you're going to get asked, literally. So that's good. If you feel comfortable with that, that's good. Let's have a look at this one here. The zoom function in a software package multiplies, so I think I already know that that's going to be a ratio question, but anyways, we'll continue. The dimensions of an image by 1.2. So pretty much my logic is telling me R is equal to 1.2. But I'm going to continue. In an image, the height of a building is 50 millimeters. After the zoom function is applied once, the height of the building in the image is 60. So that means we started with 50, then became 60. After a second application, it becomes 72. And if I did this divided by this or this divided by this, I promise you, you'll get R equals 1.2. So that's the first thing you got to work out. Now we know it's a GP. Calculate the height of the building on the image after the zoom function has been applied 8 times. Give your answers to the nearest millimeter. A equals 50, R equals 1.2. You need to work out T8, which equals to A times R n minus 1. A times R n minus 1. Nearest millimeter. $179 millimeters. You got yourself 2 marks in the HSC again. Any questions there?
No.
Double on. The height of the building in the image is required to be more than 400. I think you're starting to realize in the HSC they always use inequalities for the last question. But anyways, more than 400. Starting from the original image, what is the least number of times the zoom function must be applied? Again, what letter am I looking for? You'll be looking for n. So we know that it must be at least 400. So here we go. We've got A, R, n minus 1 must be at least 400, so greater than 400. You'll need a bit of your log laws here, so it'll be interesting to see if we still remember this log law. But here we go. 400 divided by 50. 400 divided by 50 is 8. I don't know if you remember these log laws, but this is the one that we need. You log both sides because it's the power of an exponential. As you log both sides, you've got a power of x. You are allowed to bring that power down. And then technically, you just divide by log 2. So if you had a question and the question was to solve 2 to the power of x equals 3, your answer can straight away just be written as x equals log of the right hand side divided by log of the left hand side. So in that case, this guy becomes n minus 1 must be greater than log of the right hand side divided by log of the left hand side. Steph, do you actually remember this yourself from year 11?
Sort of.
And then what about you, Azra? Do you remember this at all from like what we did? Or
Yeah.
Yeah? Okay. So power, you're allowed to log both sides, and then if you log both sides, technically the power can come down, and then you can divide, or you can just memorize. Like me, I just memorized log of the right hand side divided by log of the left hand side. So log of the right over log of the left. Plug it in, log 8 over log 2.1, oh sorry, 1.2 becomes 11.4.
Luke.
So therefore n equals 13. Alex, is that you?
Yeah, sorry, I forgot.
Oh, good. Oh, good. I tried calling you a few times, it didn't work.
Yeah, no, my laptop was off because it was out.
Oh, sure. That's okay. We've got this recorded anyways, so you can just go back and look through it.
Okay.
It doesn't look like we've done anything too hard, I promise you, so far. We're about to start the hard stuff.
Oh, okay.
All right, girls, all good with that?
Yeah.
All right. And like I said, we're just about to start what we were doing last week, which is all that superannuation loan repayments. There we go. And that's how it's going to be. It's going to be a whole bunch of words, won't really be broken down, and then worth usually 4 marks. I think I've seen it once or twice as 5 marks, but 99% of the times it'll be worth 4 marks if it's just a single question. If it's broken up into like I, double I, triple I, and IV, then it would be worth up to 7 marks. Because I'll break it up into a few different stages and so on. Okay. Who wants to do this one with me? Alex, you know what? Let's do it together, you and me. Since you came now, you might as well let's start with this one and see if you're comfortable with it.
Okay.
A super fund, which means we're increasing only. There's no withdrawals, right? So no repayments. So a super fund pays an interest of 8.75% per annum, which compounds annually, not monthly. So we're not going to divide it by 12 or anything like that. Stephanie decides to invest $5,000 in the fund at the beginning of every year, commencing on 1st of January 2003. What will be the value of Stephanie's superannuation when she retires on the 31st of December 2023? I think we did this last week.
Yeah, I think we did.
Yeah. Because I remember you guys saying, oh, is it 20 years? But I said, no, it's actually 21 years.
Yeah.
All of them? Let me just have a quick look.
No, I don't think we did that one.
Yeah, that one doesn't look right. All right, let's do that one. Sorry, Alex, we got to do this one.
It's all right.
A person wishes to retire after working for 30 years. The super fund pays interest at 14.5% per annum. How much should be invested? how much should be invested at the beginning of each year in order to receive a lump sum payment of 300,000. So a bit different. You actually want to work out how much you got to put in every year so that after 30 years you can have 300,000.
Okay.
Okay. Do you know what we're going to do? Do you feel comfortable with this, or?
I don't feel super comfortable, but I think I have an idea.
All right, wait, let's see. If you can get A1 out, then we'll continue. So A1 should be the amount that you would put in, which is what? What are you going to say? You don't know the amount, so what are you going to say? If you don't know something, then what would you usually represent it as?
It's like a letter?
Yeah, a letter. In this case, we're just going to pick P because usually our formulas are P1 plus Rn, let's say. Okay, so P, and then bracket 1 plus
14.5.
And that's how much you would have put in the first year. Is that correct?
Yes.
Do you understand that?
Yeah.
All right, then we're going to be able to continue, I think. Let's see. I just don't like it written like this. We simplify that to that. Okay. What happens in A2? Think about it. What happens in A2?
We kind of get the same thing, but then we times 14.5 to it? Or 1?
No, tell me it again. Think about it. A2, what would happen? What you did in your first year, you put some money in, and then it grew. In A2, what must happen right at the beginning? What must you do?
You must have what remains from the last month.
Okay, I'll
year.
accept that. Yep, so it's going to be A1, I accept that, plus something.
Would it be like P?
Yes, right? Because what's going to happen is you're meant to be investing at the beginning of each year.
Yeah.
So it'll be A1, the amount you had left, plus more money, the same amount. That's going to grow. That's what you were trying to say.
Okay.
So 145. And then A1 is this. Plus P, and then that grows. Yeah, A1 plus P times by this, and then just expand it. And let's see if these numbers make sense. It's important for me that you guys can see the numbers making sense. Look, this one says the first amount of money you put in, the first P, grew to the power of 2, because it's been 2 years, which makes sense.
Yeah.
The second one you put in, which is the one that you just put in now in the second year, grew for the 1 year. To me, that makes a lot of sense. Let's try A3. What happens in A3?
They would have grown 3 times?
Yeah, I know, but tell me it slowly. Like, I would like you guys to know the first line.
So it'd be A2?
Yep.
Plus P?
Yep.
Then times that by 1.145.
Beautiful. And then that becomes A2, which is all of this, so it'll become P 1.145 cubed plus P 1.145 squared plus P 1.145. I think you guys did it that. Okay, so the first one I put in grew for 3 years. Second one I put in grew for 2 years. The last one I put in grew for the 1 year. Cool?
Yep.
Fix that up. P 1.145. All right, brilliant. And then what? Okay, and then we also said, I don't like him decreasing in powers. We like him increasing in powers. So I'm going to save myself some time and just get rid of these powers and do this. That becomes a power of 1, that becomes a power of 2, that's going to become our power of 3. Now, you actually know how many years this is going for. It's going for 30 years, right? So you're going to go dot, 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 A30. What does A30 become? Well, that becomes all the way up to what?
30?
So P 1.145 power of 30. And then what do you do? Do you remember?
I think we like
Factorize. I'll help you out. It's all good. Factorize then. There it is. Then what are you going to be left with? You're going to be left with 1 plus 1.45 plus 1.145 squared plus dot 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 until 1.145 to the power of what?
29.
29, because this is going to be a 29 plus 1 more gets you back to your 30.
Mm-hmm.
And then what does A30, what should A30 become? So what's the amount after 30 years? Read somewhere in here. Read the question. Maybe
Is it 300,000?
yeah, right. Because you wanted to make a lump sum payment of 300,000. So your 30th, your amount after 30 years has to be 300K. Does that make sense, Alex?
Yes.
And then pretty much, look, we've got 300,000. We've got this. We just want this mess simplified. And it's very easy to simplify that because both superannuation and loan repayments are all going to be GPs. So this one's going to be A, which is 1, R to the power of N. What's N?
N.
How many terms are there going to be here?
30.
30 minus 1 over R minus 1. And I think you guys can see it's just the answer for P is literally going to be 300K divided by both of these. So let's see if we can all do that in our calculator. Personally, if I was putting this in my calculator, I'll just use this first, get this as an answer, and then just do 300K divided by answer. So that's what I'm going to do. Times 1.145 and then 300,000 divided by that. Cool. Why does that sound
I got
good?
that.
You got that as well?
Yep.
It sounds super high. I mean, like super low. $600? Seriously? Is that just? I don't. I mean, I don't doubt it because I know 14%. It's just, could I have done something wrong by any chance? No, seriously, 600. Wow. All right, there you guys go. By only putting $600 a year, you can have $300,000 after 30 years. That's the power of compounding. That's a lot of money. If you want to work it out, I mean, 600, if you just times it by 30, you can see you've only technically put $19,960 over the 30 years. You have only put $19,000 over 30 years just from the compound, just from the power of compounding has made you $300,000. That's amazing. But it is important to note the rate is 14.5%. So it's pretty high. Okay. Girls, any questions from that?
No.
All right. Cool. Oh, there's a 7 marker one I was talking about. How many markers is this? 3, 4, 5, 6. There you go. 6 marks. Paying off one. All right, last one. I'll first let you read it. And then Steph, you and I will do it together. Just read it first. And we're only going to answer I, so only read I. Don't need to read anything else. Let me know once you've finished reading it. We'll start.
Okay.
Okay, let's do it. Mr. and Mrs. Kane each decide to invest some money each year to help pay for their son's university education. The parents choose different investment strategies. Mr. Kane makes 18 yearly contributions of $1,000 into an investment fund. He makes his first contribution on the day his son is born and his final contribution on his son's 17th birthday. So how many years is that? Well, if the first one's when he's born, on his 17th birthday, technically there has been 17, right? Let me think about that. On his first birthday, there would have been, no, on his first birthday, he would have technically had 2. So on his 17th birthday, there should be 18. Anyways, we'll come to that in a second. His investment earns 6% compound interest per annum. Find the total value on his son's 18th birthday. Okay. Let's do it. And his final contributions on his son's 17th. Yeah, of course. All right. Steph, did you firstly, like, I think we know what our contributions are. Oh, even says makes 18 yearly contributions. That's not fun. I was hoping that they didn't tell us that. But now you know what n equals to. It's 18. I was going to say, Steph, do you understand that if you started the first one when his son was born, and the last one on his son's 17th birthday, that it actually becomes 18?
Yeah.
But if that was too tricky, I don't know if you were hearing my working out. I said, okay, if the son was born, right, how many contributions would he have done on his first birthday? On his first birthday, you would have already had 2 contributions. Because your first one would have been when he was born, and the second one would have been when on his first birthday. So if the number is 1, then it must be 1 plus 1, which is 2. If the number is 17, it's going to be 17 plus 1, which is 18. Cool?
Yep.
All right. That's 1,000, 6%, and I think we're just going to do everything we just did with Alex and get ourselves 3 marks. So let's do it. A1 becomes $1,000. 1 plus, what was it, 8%? 6%?
6.
So 1, instead of plus, we might as well just go 1.06. There it is. A2 would be A1 plus 1,000 times by 1.06. And then A1 is obviously that, so you're just going to get okay. Steph, give me A3 in ascending order. So start with the smallest one. What should A3 be?
1,000. 1.0 times 1.06 plus 1,000 1.06 squared, and then 1,000 times 1.06 cubed.
When did you get like? So it's okay. I was going to say, when did you get this one, or where did you get this one from? You would have got this one from the fact that the very first investment has grown for 3 years.
Yeah.
This one here for 2 years, and obviously this one here for the last one you just put in. Okay, and then A18 becomes 1,000, 1.06 plus 1,000, 1.06 squared, dot, until 6 to the power of 18.
18.
Okay, and then what are you going to do now?
And you need to factorize it.
And what are you left with here?
1 plus 1.06 squared. 1 point, yeah.
That's fine. Yep, and then plus?
Plus 1.06 to the power of 17.
And then next line, last line. What am I going to put in?
We put 1.06 to the power of 17.
Wrong.
No, 18 minus
Because
1.
there's one more here.
Yeah.
Right? Minus 1 over.
Over 1.06 minus 1.
Okay, and then just plug all that into your calculator and we should get 818. Alex and Azra, all good with that one?
Yep.
Yeah.
$32,759.99. So after 18 years, I think 6% is just about right for an average. So after 18 years, which means $18,000, that money would have grown to $32,000. So not bad, not bad at all. He made an extra $14,000 for his son. B or double I, whatever. Azra, let's do this one together.
Yeah.
So, you know, when you've read double I,
Yeah.
all right. So this one's a little bit different, isn't it? What it's saying, you're not just putting $1,000 each year, you're deciding to increase that amount that you're contributing each year by 6% as well. And then your investment still grows for an extra 6% as well. Not a problem. We're just gonna do the math properly and it should work out. Alex and Steph, you've read it, you understand what it's saying?
Yeah.
Yeah.
So you're going to put $1,000 every day or each year, sorry, and then you're going to increase that. So next year you're going to increase it by 6%, but you're still going to earn 6%. And then the question just says, find the total value of Mrs. Kane's investment on her son's 3rd birthday, just before she makes her 4th contribution. So don't include the 4th contribution, it's trying to say. All right, let's see what happens. So A1, Azra, what do you want to write? So the
Be
date,
1,000
yep, times,
times the 6%.
correct,
Oh yeah, no. Yeah.
done. All right, A2,
And then A2 would be
A2,
A1
yes, A1,
times the 6%
uh,
again, because it's increasing.
so you're not increasing A1 right now, right?
Mm-hmm.
So, hold on, have a look at this. So this was A1 plus the contribution, then that whole thing multiplied by 1.06.
Yeah.
Now, so it's not A1 times 1.06, it will be A1, what?
You'd add.
Add, that's what I would like to hear. Add,
Yeah.
now it's not 1,000. It's
Mm-hmm.
going to be 1,000 times by,
1.06.
yeah, and then all of that is going to multiply by what?
1.06 again.
Yeah, and let's see if this makes sense now. So have a look at the one on top. We wrote A1 plus 1,000 times by 1.06. Same thing. We wrote A1 plus our new contribution, which has to be 6% greater than $1,000, and that's what it would look
Yep.
like, times by our growth for the whole term, the whole year, whatever. Good. I think you get that. As Alex, Steph, did that also make sense, what I did there?
Yeah.
That's
Yes.
how you would do the increasing of 6% for your contributions. So the logic can't change. And that's why I'm very hesitant sometimes writing A3 like this. I like you guys to get used to knowing like A2 plus this times it. It just works a little bit better, especially as you're beginning. And then again, A1 is this. So, you know, I don't know, write 1,000, 1.06 plus another 1,000. Well, that works out the same thing, isn't it? Anyways, we'll get to that in a sec. Times by 1.06. So 1,000 plus 1,000. Don't add them yet. Just leave them. Let's just multiply it over. That becomes 1,000. 1.06 squared plus 1,000. I know they're the same, so technically you should write, you know, 2,000. 1.06 squared. I'm hesitant doing that because it might just have happened because of A2. So let's just continue to do A3. Azra, what are you going to write for A3 now?
Would you do A2?
It'll be A2 plus 1,000.
1,000. 1 point times 1.06. And then that whole thing times.
Incorrect. So think about it. In A2, right? A2, it grew for 6%.
Yeah.
In A3, do I just use what I used in A2? Do I just put the same amount of money in?
You times that again.
Yes, you mean that.
Yep.
So how much are you going to put in A3? Well, you're going to be putting in 1,000 and 1.06 squared. You're increasing it by another 6% the next year.
Yeah.
Okay, stop there. Alex, Steph, does that make sense, what I just said?
Yeah.
Yeah.
Okay, and then times that whole thing now by the growth rate. So then A2 is, you know, this thing. So then as I expand this with this, that becomes what? 1,000, 1.06 cubed, plus again 1,000, 1.06 cubed, plus 1,000, 1.06 cubed. And I think now we can safely say, yes, this was 2,000, 1.06 cubed. Sorry, squared. This is now 3,000, 1.06 cubed. So 1,000 plus 1,000 is 3. She makes her fourth contribution. She's made the second contribution. Where is it? There, right there. Second contribution. She's made her third contribution. What would it be on her son's third birthday? No, it would be that, right? Do we all agree with that? Just before she makes her fourth contribution.
Yeah.
Azra, are you happy with that as well?
Yeah.
All right,
So this is before his birthday, right?
Yeah, just before his birthday. So before she makes the fourth contribution.
Okay.
So the first contribution, there it is, 1,000. Second contribution would be 1,000 and like $6 or whatever, and then the third contribution would be a little bit higher than that, like $1,008 or $12, whatever it is. Just before she makes the fourth contribution. Cool. Mrs. Kane also makes triple I. Mrs. Kane also makes her final contribution on her son's 17th birthday. Find the total value of Mrs. Kane's investment on her son's 18th birthday. Well, we can see the pattern, so that's very nice. For triple I, the final what was it? Find the final amount. Find the total value. We can actually tell this one's not going to be like a series, right? It's not going to be like this one where it's a big mess and you're putting $1,000 in. It's actually working very nicely. The amount would just be on the 18th birthday. Again, you're only doing it for 17 years. So because you're putting on the last day, the last amount is on the 17th birthday. So that will be A17. Sorry, A17 becomes $17,000 you would have put in. No, wait, $18,000 you would have put in. So if that was A3, that's the amount you had just before your 4th birthday. A17 would be on your 17th birthday, just before your 18th birthday. Yeah, correct. So 17,000, 1.06 to the power of 17. And this way, the mum has made the son $45,000. So by just increasing each year by 6%, the mother was able to increase her amount for the son by an extra $13,000 as well. Not bad, right, you guys? Like once you understand this, you can realize how much just a small little difference can make from the power of compounding. Any questions with that?
No.
No.
Okay. I think we're up to loan repayments. Let's just do Peter retires, the lump sum of 100,000. Yeah, we're going to do this one. Oh no, we did this one last week. Okay. We did that one last week. Can I set up a prize fund with a single investment of $1,000 to provide a school with an annual prize value at $72? Fund accrued interest and rate. No, I don't like any of these just yet. Just yet. Okay. All right. We're going to do this one. But I'll first, I don't know. I don't know if I would like to see you guys try it. Actually, let's do a superannuation question. I just want to make sure you guys can do that before we do loan repayments, because loan repayments is just a little bit harder. So let's do one question. Where is this? Okay, question 3. Can you guys do that for me? So an amount of $3,000 invested in a super fund at the start of each year. The interest is interest at a rate of 9% per annum is paid every half a year, which means you've got to do it for 4.5% every half a year. And how much is the investment worth after 18 years? That means your N is going to be for 36 half a years. So 4.5%, and you're doing n as 36, just so you know. Can you guys start that for me? And then I'll do it in about 5 minutes or so. I just want to see if you guys are getting used to the whole compounded style of questions. Let me know if you find an answer.
I got an answer.
Okay. What's your answer?
I got 270,124.
$270,000.
124.
Can you tell me your? Let me just have a look at it because I feel like we'll know if it's right just by seeing what your thing is. Okay. What's your what's your last line or second last line? Sorry.
Is 3,000
Yep.
times 1.045
Yep.
times by 1.045 to the power of 36 minus 1 all over 1.045 minus 1.
Okay. I'll wait for the others. See if they agree or disagree.
Yeah, I got the last line. I'm just putting it in my calculator now, but it should be the same.
Yeah.
Wait, Sam, I'm a bit confused because in the question it said it added 3,000 at the beginning of each year, right?
Yeah. Yeah.
But this one like compounds like I think is it a month
Yes.
or is it every half a year? So how would you do that? Because I'm a bit confused on that.
Yeah, I started off because I thought the same. Like I divided the 3,000 by 2, because it was half year, but then I changed it.
So it's good. It's okay. Good point. Like Azra, the one you've got is for you assuming that, for example, you put $3,000 every year, and then your rate is 4.5% every 6 months, and then for 36. Let's see what happens in the case of what you're saying, which you've read it pretty much perfectly. The fact that it's $3,000 at the start of every year, and then your interest is paid every half a year. Let's see what happens in that case. So A1, right? The very first year, Alex, you put $3,000 in, and you got compound interest at 1.05 every 6 months. So that means at the end of the year, it would have been what? To power off? 2. And what would have happened in A2? A2, it would have been A1 plus you would put another $3,000 in, and then that would have gone for every 6 months, power of 2. So yeah, Azra, I think your answer's going to be incorrect as well. It would have been right, Azra, for the normal cases. But this case, you're putting $3,000 in only every year, and then it's growing for the 2 periods in that year. And then A3. A3 is going to be A2 plus you put another 3,000 in. And then A2 is 3,000. This makes sense, Alex, now?
Oh, yes, it does.
And then, of course, we rearrange. And I'm just going to rearrange and factorize all at the same time. 1 plus 1.345 squared plus 1.345 power 4. And then, of course,
Wait, Sam.
yes.
Why is it going up by 2?
Why? Well, it just happens, doesn't it? But are you trying to say why was it squared in the beginning?
Yeah.
Okay, right. The first year, at the end of the first year, what would have happened? You would have had 4.5% every 6 months.
Yeah.
And then for how many 6 months are there in a year?
2.
2. That's power of 2. Like that would have grown for 2.
Yeah.
2, yeah.
But then why would we just not write it as 1.09?
Oh, good point. 1.09 would be power of one period, right?
Yeah.
But if you compounded something for 1 year compared to compounding the exact same thing for 2 periods, which one's going to give you a higher answer? The one that you compounded once, or the one that you're compounding twice? Or do you feel like they're going to give you the same answer?
Yeah, like I feel like it'll be the same.
Well then, but then, okay, that's like you saying, if you, how can I say this? All right, if I gave you $100 and you put $100 in compounding, so adding on top, right? Compounding once a year compared to once a day. And even if the rate was the same, so let's just say this was, I don't know, 10% a year, and then for a day you have to do 10% divided by 365. Don't forget, what happens with compounding is once it works out the interest, it gets added on top. So do you want the interest to get added on top every year? Would that give you the same answer, or every day? I mean, which one would give you a higher answer?
The day.
If it's compounded every day, because the interest on top every day, even if it's going to be 10% to the power of 365. Like, even if it's going to be, if what you think, oh, that's the same, I might as well have just done it a year, but you would want it every day. It's going to give you a higher number. And then if you want to check it out, I mean, literally plug that into your calculator and plug this into your calculator. It'll give you a different answer.
Okay.
And that's why, like, usually you would want things done monthly or as frequent as you can, because they become a higher number. And that's why, like let's just say credit cards are actually compounded daily, because the banks make way more money from it being compounded daily than if they were compounded monthly or weekly or anything like that.
Yep.
But yeah. So no, it's not the same amount, unfortunately. And then trying to do a what? Well, in this case, if we're doing years still, a 1 year, 2 years, 3 years, you're going to do A18, isn't it? Instead of A36. I stuffed up. I told you guys 36. With my bad. It's power of 2. And then what? Y1 plus 1.045 squared plus all the way until the last term. 3 times 2 is 6. So 18 times 2 gets me 36, which means the last term would be 34. How many terms would that be? 18 minus 1. Plug that into my calculator. Alright, I think we've got to do this one together, because there's a few little tricks everywhere. It's 3,000 every half a year. That's why. Didn't work out. I'll give you a number. Let me know when you want me to explain this, unless it's all making sense. What I've got on the screen.
So, why at the bottom is it squared?
Why at the bottom is it squared? At which stage? Where are you looking at?
Like
Yeah.
second last line.
Second last line. This one here. Why is it squared?
Like on the fraction.
This.
No, like on,
Yeah.
on the fraction.
Yeah.
At the bottom.
Okay. Well, what's R? What's R? What's it going up by?
Oh, it's going up by 1.045
squared. So
yeah.
that's R to the power of n. There's going to be 18 of them.
Yep.
Minus 1 over R minus 1.
Yeah, okay. Yeah, I got that answer.
Nice. Azra, Steph, does that make sense? What we've done with this one now?
Yeah. Yeah.
It's a bit weird, but oh well, that's how it works. That's what we can do. Just like that. All right, try this. Now my clue for you, just try it. Actually, just try it, and then we'll do it. But at least get you can get up to 30. So do that stage first. I think we can safely say we can get to the 30 bit easily. So man contributes 1,200 each year into a super fund for the first 30 years, and then at least do that. So work out the total amount at 30 years, and then we'll do the next bit together. Because we've got to do 2 different sequences. A30 should be what? I think 1,200 paid yearly, so it should be just 1.08. 1.08 to the power of 30 minus 1. Did anyone actually prove it out and get this result? Still working on it. I think that's right. I'll wait for you guys. I know, just an educated guess.
Sam, in the question, I don't think I read it properly, but did they give us the percentage?
Yeah, 8%.
Oh, okay. Yeah, got it.
You agree with that?
Yeah.
Yeah. Okay, cool. I'll wait for the girls.
Got that.
Nice.
Yeah, I got it.
Okay, let's do it. So that's 8:30. Then it's saying, which did anyone actually work out the answer?
No, I'll put in my calculator now.
Okay.
Yeah, it's 146,815.0416.
Cool. So a man contributes $1,200 each year into a super fund for the first 30 years, and we got used to it's kind of somehow look like that. For the next 15 years until retirement, he decides to increase this and invest a total of $5,000 each year. If the investment earns 8% for the whole period, how much will the investment be worth upon retiring? Well, what happens in A31 now? Well, A31 would be this number, which we're going to call A30, plus $5,000. And that's going to grow for 8%. I hope you guys would have assumed that. And then, you know, 830 is, it's just easy to write 830. I'm just going to leave it as 830. I can't bother to write this whole number out. 1.08 and then plus 5,000. What's A32? A32 would be A31 plus 5,000. Then that grows. So A31 is A30 times 1.08 squared plus 5,000 1.08 squared plus 5,000 1.08. Let's just stop there for a second. Let me know if you're still with me up to this stage.
Yep.
Okay, girls?
Yeah.
All right.
Yeah.
So look, let's see again, let's see if the logic makes sense. I really like to know that the logic should always make sense for these questions. A30, you're in the second year after your 30th year, right? Well, your amount that you had would have also grown for 2 years. Not anymore, right? The amount you would have had, which is this amount, would have grown for an extra 2 years. So that makes sense. Then the amount you would have put in the very first time in your first year would have also grown for 2 years. There it is. And then the last payment you just put in, the 5,000, would have grown for the 1 year. So that makes a lot of sense to me. That's great. And then, of course, from there you can generalize. I hope you can generalize for A45. 5 would be A30. 1.08 to the power of 15, because it was 32, it was 2, so therefore 45, it's going to be 15. Plus, we're going to increase here, so 5,000, 1.08, plus 5,000, 1.08 squared, plus dot dot dot, plus 5,000, 1.08 to the power of, when it was 32, again it was 2, so therefore if it's 45, it's going to be is the first one you had, this new amount, and then it should be to the power of n minus 1 over r minus 1. What do you guys think? That all makes sense?
Yep.
How'd you get 15?
This bit, how did I get 15 for this?
Yeah.
Okay, well, if you knew it was A31 and you had the power of 1, which means you had to subtract technically 30 if you want to think of it like that.
Yeah.
If you had 32, it was 2, 2, so therefore you took away 30 again. If it's 45, you're taking away 30 if you want to think of it like that. Otherwise, you know that up to 45, it's taking you 15 years from 30.
Wow, okay.
So at 45, it's taking you 15 years from 30. So I just thought of it like that.
Okay.
Cool. And then the rest all makes sense?
Yes.
And so yeah, look what I did again. I don't expect you guys to go from here to here straight away, right? It's not like that. It's really meant to be broken up. First trying to work out this, then trying to expand. Every time you get stuck, just do it like that. Do a little bit more lines. It's okay. At least the logic of it will make a lot more sense this way. And then there's no room for error really. And then now you might as well put what A30 is all of it into your calculator, and you should get a nice big answer, which I'll leave for you guys to do. All right, loan repayment. Okay, so almost 7:30. Let's do a loan repayment question now. Pretty done. All right, let's do this one. I'm going to finish off with this question. Peter retires. Wait, this is a different. No, is it? Peter retires with a lump sum of $100,000. So that means he pretty much has $100,000 saved. The money is invested in a fund which pays interest each month at a rate of 6% per annum. So it's going to keep growing at 6%. Peter receives a fixed monthly payment of M dollars from the fund, so he's allowed to take away M dollars every month. Thus, the amount left in the fund after the first monthly payment is this. So can you see how this is a loan repayment, not a superannuation? And the reason why it's not superannuation only is because he's allowed to subtract some repayments out. But this would be a loan repayment question. Find the formula for the amount AN left in the fund after n monthly payments. Well, as always, we always start with A1. They've given us what A1 is, but I like to work it out with you guys. So we pay interest each month at a rate of 6% per annum. So that each month means, what do I got to do? 6% divided by 12. And we're doing monthly payments. So A1 is months. So this is in months now. So A1 is 100,000. What's 6% divided by 12? 6% divided by 12 0.005, so it becomes 1.005. Cool, it grew for that month, and then you took away M dollars. And then if you plug this into your calculator, I'm sure it'll give you that amount. All good? A2. A2 is going to become A1. You're not putting any more money in, right? So it's just A1's amount. That's going to grow. And then grew by M. So that becomes 100,000, 1.005 squared minus M, 1.005 minus M. Do you guys get that?
Yeah.
A3 becomes 100,000. Sorry, let's do it slower. A3 is whatever I had in A2 grows, then I take away some money. So again, A2 is this, so it becomes 100,000, 1.005 cubed minus M, this times this becomes minus M, power of 2, this times this becomes minus M, and then the last one, minus M. And then I like to write them, as I keep telling you guys, in ascending order. Okay, and then AN. So any letter, any term. Who wants to give it a shot? 100,000. Bracket. Yeah, go ahead.
Then you have 1.005
Power of
power N.
N, because if this was 3, this was a 3. So N minus, I'm going to factorize my common factor, which would only be M. It would not be 1.05 because this one doesn't have it. Then I'm left with 1, that's this one, plus 1.005 plus 1.005 squared plus dot 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 plus 1.005 to the power of
N minus 1?
Yeah, 3, 2, 1 less, N, 1 less. N minus 1. Close bracket. And then pretty much you're done there. A, R, N minus 1 over. All good?
Yep.
Yeah.
All right, beautiful. 2 marks. Peter chooses the value of M so that there will be nothing left in the fund at the end of the 12th year, i.e. after 144 payments. Find the value of M. Okay, simple. So what does N equal to?
12
No, 144. Why? Because you're doing these in
months.
months. Right, you're doing it every single month. This is what you're taking out. We did it monthly, divided by 12. So N equals to 144. So therefore, you're just going to sub everything in, and the amount that's left, we said is 0. So we know the amount left after 144 months is 0. So 0 equals 100,000, 1.005 to the power of 144, and then pretty much, what did we say last week? We just said you'll just do this divided by this. A divided by B. And that was worth 3 marks. So technically, all of it's worth 5 marks, and obviously B, the 3 marks was a lot easier than the 2 marks. Because there's a lot more work in the 2 mark than there is in the 3 mark one. Any questions? I'll get the answer out for you guys. Steph, did that make sense as well?
Yeah.
I'm just plugging it in. It looks like $75.85. So as long as he takes out about $1,000 every month, after 12 years, he actually will have $0, even if it's growing. So even if this amount was growing, as long as he takes out this much, he'll end up with nothing at the end of 12 years. So technically, it is a loan repayment. It's just done differently. So usually the questions were you're borrowing 100,000, and then the banks were charging you 6%, and then you had to pay back a repayment. This one's exactly the same. It's just in the, I guess, in the eyes of the bank, the bank has $100,000. They're giving it to you at 6%, and then you just want to work out what you're allowed to take out every month, so that at the end of the 12 years or 144 months, you're left with nothing owing, I guess. Okay. Any questions for me from there?
No.
No.